This is Sai Vignan Malayala. So my overview for the session actually would be discussing on RNNs and CNNs, the advanced neural networks. But before going there, I just want to give an overview of what's a neural network. Okay. So before going to the advanced level, we need to have the basic understanding of machine learning, which I am expecting you all have. And secondly, I want you all to know what's a basic neural network also. Okay. So for just next few minutes, I'll discuss the basics of neural networks and then start with CNN and RNNs in this session. So what's a basic neural network? Okay. Uh, so let me take an example instead of giving a theory kind of scenario. So I think all of you have an idea of linear regression, the basic machine learning algorithm, right? So let me take an example of linear regression. Like there is some, suppose an example, you want to predict the cost of a particular land based on the size of the land. Suppose I take an example like scenario like there's a land of 100 yards and the cost is 10 lakhs, and there's a land of 1000 yards, the cost should be 20 lakhs. And and the similarity goes on. So if I take this example, what would you do? You obviously would try to get the best fit line, right? You would plot. Suppose I have five points. No, suppose 500 yards and uh, 10 lakhs, 1000 yards and 20 lakhs, or 22 lakhs, or 19 lakhs. So what you would do? I suppose I have 5 points, the real time points. You would try to get a best fit line based on the y equal to mx plus no, error value, and you would try to get a best fit line and make your model. So even if I ask tomorrow what would be the cost based on certain prediction of certain size, then you would say the line goes this way, so this might be the cost around. Okay, right? This is the basic scenario of linear regression with finding the cost of a particular land with the size of the land. Let me take the same thing, the one feature. What is the one feature here? We have only one feature, that size. We are trying to take the size and predict the cost. The feature we are using is size of the land, and the prediction output is cost of the land. So let me take the same scenario and apply it with neural networks. So I will take into consideration one single neuron. Because we have one single feature, I will take one single neuron. So in neural networks, I would say uh, like we have y equal to mx plus c kind of curve. In neural networks, we have a better ones like ReLU. ReLU is an activation function and tries to get the best fit line for a particular scenario. Okay. So what neuron will do in neural networks? What neuron will do in this scenario? So neuron will take the input, apply activation function like ReLU, and generate output. Okay. So let me show the graph of ReLU first. Right. So ReLU is this. So the function of this is so what I said, the neuron, what it will do, neuron will take the input, apply what activation function, the ReLU, and then generate output. Okay. So ReLU, the function works is like max of 0 comma value. So if the land values, or if the value is less than 0, the prediction is 0. If the value is more than 0, the value itself. Okay. So in this case, we have single neuron. The neural network will apply ReLU activation function and generate output. Okay, so it's clear. So just like you are predicting this way, in neural network predicts this way. That's almost similar, because we have single neuron and we have linear network. I mean, basically linear inputs and linear outputs. Okay, right? So that is how we have converted a simple linear regression to a neural network model using ReLU. Okay, so this is with single neuron. Okay, because we have single feature. What is the feature? Size of the land, which gives the cost of the land. Now, obviously, in the real time scenario, we can't predict the cost of a land based on one single input. There are multiple other features, right? Like you might get the cost of the land based on different scenarios, like the popularity of the land, the the area where it is present, the zip code, the neighborhood, what is the neighborhood of the land. So based on different scenarios, the cost of the land differs, right? So in this scenario, we can't use a single a neuron or a single feature. We have multiple features, so we need to use a multiple neuron based networks. That's how I'll go to little bit next level. That's a perceptron. Okay, what it's called perceptron. It is little complicated but not much. Okay, so how do you define a neural network when you have multiple inputs? Okay, suppose there are three inputs. Suppose I say the size of the land, and the popularity of the land, or the zip code, and the neighborhood of the land. What is the neighborhood? Are there any hospitals, are there any schools nearby the land? Based on that also, I mean, the cost of the land differs, so we are trying to predict the cost. So we are giving three inputs and applying to a activation function, and then giving the output. Activation function, we are using relu in this case also. Okay, so this is how a multi-layer I mean neuron based network, it's perceptron, works. Okay, so the advantage in using neural networks compared to your linear regression model here is, see, when I take suppose the the second feature, like the zip code or the popularity of the land, that also take into consideration, uh, like how much far is it from the nearest popular location, right? So that is what the perceptron or the neural network does. Based on your random inputs, it tries to take your features, and also if you apply a hidden layer, it will take multiple more features. So even without giving a feature, it can try to recognize more features and give you the output. Okay, so we passed suppose we passed three features here. So the neural network, it automatically identifies some hidden features from the input and generates the Y output. Okay, so you can have multiple hidden layers. So I have four inputs, so this is a hidden layer and the output. Okay, so based on my inputs, there are multiple features being recognized and giving me the output. So that is the intelligence coming into picture with a neural network. It is not just your features, it is trying to get more features and trying to get the best outcome based on your inputs. That is how simple neural network works: input, hidden layer, and output. Okay, fine. Maybe a little more detail before going ahead. So, uh, I said what is an activation function already, right? So neural network actually has three layers. One is input layer, hidden layer, output layer. So input layer, what you could say is it is the starting point of the network. So values here used to predict are what in here. Okay, the input values basically. And secondly, we have hidden layer. So hidden layer, I can call it's a magic layer. It's a magic layer. All the magic happens in the hidden layer only. Okay, so the activation amount of input values are calculated here. Okay, this can be one or more layers. It depends on the data set and the requirement. And thirdly, output layer. So here the activation of uh, uh, I mean the activation of each of the find nodes is used to select the solution. So it's basically trying to approve a transaction or approve a result. So this is the you know output layer where activation function also has the intervention, and it is trying to approve whether a particular result is going out or not. Okay, so now if I say what's a neural network, I think it's pretty clear for you. If there are more than one perceptrons present and joined in a layered fashion, okay, it's a layered fashion, we have a neural network. That's all. So what is a perceptron? A single neural network layer, single neuron layer. So if you have multiple perceptrons, that's when you get a neural network, and it has multiple layers, so it's a layered network. Okay, so here what happens? The output from the first layer goes to the input of the second layer, and goes on to the activation function, and the activation function finds the confidence level and makes the final decision for the output. That's simple. A neural network. I think with this definition, anyone who wants to understand what is neural network becomes clear. Okay, so simple, right? Great. Okay, let us move a little forward. Okay, so what are how do this neural networks learn? How do they learn basically? uh, we are giving inputs, we have hidden layers to identify features, there is activation function to approve no the threshold and give the output. But still, where is the learning happening? So there are two ways how the learnings happen in a neural network. So one I can say is feed forward way, and second is back propagation way. Okay, so how do they learn? There are two ways: feed forward way and back propagation way. Okay, so in feed forward way, the data travels from one direction. That's all, input to output. Okay, uh, so basically in feed forward way, the results are very faster when you apply the model in real time, but the training is very slow. And most of the vision and speech recognition API, most of the vision and speech recognition based applications are run in feed forward way only. Okay, so it is what simple one direction way, that's all. And what is back propagation? It's like whenever you give an input, it goes feed forward from one direction and goes back to relearn. That's how it learns. Okay, suppose I'll give an example. uh, you have you have an no example, you already have an example, the land example, right? So based on the size of the land, you're trying to predict the cost of the land. So I gave multiple inputs, and then the the model has tried to predict that based on this value, 500 yards, the cost of the land could be maybe 8 lakhs, but the actual present value in the market is 10 lakhs. So the model has understood I gave a wrong input, there's an error of 8 minus 10, that is 2 lakhs. So it will go back propagate as an input to the first layer and say, no, there's an error. So it's trying to relearn, it's not 8, it is 10, and then goes forward. And again, if it is trying to again retrain and again say it is 11 lakh, no, again it will go back and say it's 11 but actually it's 10. 10 minus, 11 is minus 1, so again there's an error gap, so I'll relearn again. So that is how neural network does back propagation and relearning to get the right accurate result. Okay, so mostly I mean, the back propagation way works well, obviously, because of the relearning happening there. So back propagation. So what it is trying to do? It is trying to minimize the cost. So what is cost? I think it's a new word. So let us note. These are the real time words we have to learn. Okay. So what's the cost? Cost is just the difference between uh, the actual, or I can say the actual value. I mean, sorry, the predicted value of the model and expected value from data set which is predefined in the market. Okay, so So that is cost. So when I say back propagation, you have to still remember the cost. So cost is what defines the back propagation. So the minimum the cost, the more accurate your model. The larger the cost, that means the greater error. Okay. So the goal of any neural network model is to minimize the cost. Okay. So what is the goal of neural network models? Or any machine learning models, I can say, minimize the cost. Basically the error gap. Okay. How do we do it? How do we do it? Yeah. So basically, uh, what happens in real time is this can be achieved by altering the weights and biases in the name of neural network game. It's a game. Okay. So by altering weights and biases, and the common method to do is gradient descent. A new word. I think you have learned a lot of words. Feed forward, back propagation, cost, and how to minimize the cost, gradient descent. So what we do to achieve this? The solution is alter weights and biases. Right? Popular method is, sorry, gradient descent. I'll explain what is this. So what is gradient descent? Okay. So getting minimum cost by summing up the difference between actual and expected output multiplied by the learning rate is called gradient descent. Little complex, right? I'll give like kind of formulation for it. So it's basically the sum of the difference of what we already did that, right, of different outputs into learning rate, right? And the most common method of doing this is doing the gradient descent is using mean squared error. I think most of you have heard, who knows machine learning, what is mean squared error. So based on mean squared error, you're trying to predict the global minimum, or using gradient descent, you're trying to predict the global minimum. Again, a new word. Another new word is learning rate. Okay. So when you're trying to predict, you have obviously the errors, and to minimize the errors, I mean, in the by doing back propagation, you're you have a popular method, gradient descent, where you're summing up all the values, no, predict minus expected for all the different nodes, and then multiplying by the learning rate, and then trying to find the global minimum. Wherever is the global minimum, based on those, you will get the minimized cost, which is the goal of a neural network. Okay, let me explain that. So there's a formula for a mean squared error. So obviously you might have all known the sum of these things minus the mean and the value, mean and the value, mean and the value. So this is called gradient descent. And now, how to minimize the cost? Right, the actual minus predicted into learning rate. Actual minus predicted into learning rate. Actual minus predicted into learning rate. Right. So this is how you learn. This is a formulation. If I just go to the value, you can. It's pretty simple. Alpha is the learning rate. Okay. So alpha, the learning rate, a way to find the global minimum. How? So how low is the step, or how big is the step? Based on that, you will define the error rate. Suppose it's like a valley. Before going ahead to the gradient descent, I can say it's like a valley. Okay, right. There's a valley. So suppose you want to get the minimum, global minimum. This is a global minimum, right, in this curve. So you initially start here. So if you take a larger step, what happens? You go here. Again you roll down to here. So there is a large error gap. Again large error gap, large error gap. So you the most of the time in training goes just to roll down, roll down, roll down. If you're here, you're rolling down. You're here, rolling down. You're here, rolling down. So to get the global minimum, you're suffocating. You're taking a larger learning rate and stepping ahead. Bigger step, bigger step, bigger step. But it is not a global minimum, so roll down. Again a bigger step, roll down. Again a bigger step, roll down. Right? So you take a larger learning rate, then what happens? You might train it faster, but still the accuracy is very low. You're not trying to get the global minimum. Or if you say no, I'll not take a large step, I'll take a smaller step, I'll do less learning rate, maybe 0.001 learning rate, very small, very slowly I'll learn. Yeah, you can learn it slowly, 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 you can reach the global minimum. But the problem is this will take lot of time, lot of time. Where are you? You might be here, you might be here, anywhere, right? And if you take a smallest learning rate, then it will take longest time to reach the global minimum. If you take the largest step, then the time might go in just rolling down, right? So that intelligence comes to you when you're training your model. You have to choose the learning rate as a hyperparameter and take the right learning rate. Say that it is not too slow and it is not getting too error, too much gap. That intelligence comes to you just right. Okay, so this is what the learning rate does and tries to get the global minimum. And if the global minimum is correct, then your error rate is less, and then you have the right less cost value, and then your network is working very well. Okay, this is another photo example, right? So this is how the neural network learns. Okay, so there are two ways to summarize: the feed forward way and the back propagation way. So the back propagation way, it goes to relearn the model. The goal is to achieve the smallest cost. That is, what is cost? The difference between the actual, the predicted value and the expected value is called cost. The minimum the cost, the better the model. And this can be achieved by using gradient descent. Gradient descent tries to minimize the cost by uh, multiplying the learning rate and also decreasing cost and finding the global minimum. Okay, I gave you the formula too. Right. So this is how a neural network learns based on these inputs, slowly, slowly, based on your hyperparameter tuning. So be careful when you train later. Huh. Right. So we have covered two things: basic understanding of neural networks and how do they work. Great. And we have learned a lot of different wordings in the real time: the cost function, the minimum, the learning rate, the gradient descent, and all. Okay, so going ahead, so what is advantage of using neural networks? Pretty simple. If you are using a large data set, if you have a large data, it doesn't work with your traditional machine learning algorithms at all, like SVM or linear regression or logistic regression. These won't work with your large data set. They don't have the capacity to work with such large data set. So that is a limitation of machine learning basic models, traditional models. And deep learning works very pretty well with a large data set to learn and train themselves. And more the data, the better the performance of the deep learning algorithms. That's an advantage. Okay, because it tries to capture the more features and better understanding. That is the first advantage. I'll just write it down before going missing it. So it works pretty well with large data, which is not possible by machine learning traditional models. Okay, and what is the second advantage? The uh, deep learning models have an advantage in considering n number of features automatically. Okay, it can auto detect n number of features. Okay, it can auto detect a number of features even without you mentioning it. You give an image to your neural network model, it can go through hidden layers and number of nodes and all. It can try to find faces even without mentioning which is ear, which is mouth, which is eyes, which is hair. Just give the data to as an image, it can find the features, which is head, which is face, and which is ears automatically, which is the color, which is the background, everything, so detailedly. That is an effect of using neural network model. It can auto find the features. Okay. Thirdly, it is highly capable and scalable with good computation. Basically, you can uh, basically you can choose a computation with deep learning algorithms. You can choose how much learning rate. No, you can choose n number of hyperparameters. We will discuss in the future too with the code. Okay, based on the activation function also you can choose which is the right activation function for the learning rate, for the computation time and all. You can trigger the learning rate based on the gradient of different activation functions. Different functions can update different parameters at different learning rates. Okay, that's an advantage. So if you use a sigmoid function, then the learning rate is little different. If you use a uh, ReLU, the learning rate is different, and based on the activation functions, you can trigger the gradient descent also. Okay, so these are the some of the advantages I can say. You can trigger every hyperparameter. That's a major advantage in deep learning. And what are the use cases? If I say, I think you already might have heard from the market how deep learning is used currently. So you have lot to say. Translation of text, identify faces, recognize speech, read handwritten text, control robots. What not you are able to do with neural networks and deep learning. Great to see this. Before going ahead, I would say we need to have proper understanding of different activation functions which are used in neural networks. So let me give a brief of activation functions. Okay. So firstly, I would start with sigmoid function. So obviously, the you might have already heard of sigmoid. The value is one plus one by one plus e power minus c. So it's like the curve, the sigmoid curve, as I'm showing in the screen. So basically, this function is used more primarily for predicting probability in your in your code. I mean in your data set. Okay, and secondly, threshold function. So threshold function, obviously one or zero, like a step function only. Okay, so this is used. Uh, I mean when you don't want any uncertainty in the middle, of your learning. I mean in the middle of your data. Okay, So if you don't want any worry on uncertainty of in the middle, then you can go for threshold functions. Thirdly, obviously, ReLU, the most popularly used one. So one, it is a value if it is greater than zero input. It is negative. It is zero if you give negative value. So it basically works only for positive values. I mean, it only accepts or approves only positive values. Okay, it's most used ReLU. ReLU is rectified linear unit. And lastly, the other popular one is tangent, hyperbolic tangent function. So it's almost similar to sigmoid function, except that sigmoid is from 0 to 1, tangent function is from -1 to 1. Okay, that's why there is sigmoid I just mentioned, 0 to 1, -1 to 1. Okay, yeah. So that with this we have covered uh, two more things: the advantages and uses of neural networks in the real time, and activation functions. What are the different activation functions? And lastly, I would mention you the different types of neural networks. Okay, so I mean different types in sense currently there are many types of neural networks being used in the market, but one of the popular ones are one is obviously standard artificial neural network. Second is RNN, and third is CNN. So I'll be discussing with code on artificial neural network, recurrent neural network, RNN, and CNN in the next sessions. Okay, so these are very important if you want to become a good deep learning master. These at least these three algorithms are necessary in neural networks. Okay, so ANN, RNN, and CNN. I'll most probably cover ANN to a little and RNN and CNN to a little detail. Before that, uh, small information on these three types of neural networks is like kind of ANNs or the simple standard no networks. They are generally feed forward, okay, and mostly used in vision and speech recognition type of scenarios. And RNN, these are called recurrent neural networks, and the word says recurrent, that has a significance. So here, the neural network saves output to be used for future prediction. So every output is an input again. Okay, every output is a past of new input. And some of the popular use cases in RNN is text to speech, and thirdly CNN. So this ANN, input hidden layer and output layer. This RNN. So every output is an input. See, A got an output. This is again an input. Okay, and if you go in detail with multiple neurons, this is the case. No, input output, like it will rotate. Okay, like it is learning every time. JAZZ. So it is learning from the new inputs. Okay, so that's how RNN works. And so there's also a complex RNN. And lastly, CNN. So the advantage of CNN, also very popular neural network, CNN. So here the input features are taken in batches as if it's a filter, like shown in the figure. Okay, so basically this is the uh, you're not training completely. You're training in batches. You're training in batches like a filters. Okay, that's why when you train an image in CNN, even if you again even if you want to predict some smaller value of an image also, it will work. Suppose you gave you in your image you have a face, you have a building, you have a traffic signal, everything. So even if you try to predict a traffic signal, it will try to get, because it is taking into batches and training faster, and also taking n number of features here. and there are a lot of other layers. I'll explain in later. But the main functionality compared to other networks is it trains in batches, and it takes multiple input features again there. So this helps the network to remember an input like an image in parts. And the examples is obviously image processing, facial recognition, uh, kind of scenarios. Great. So with this, we have covered the overview of what is a neural network, how do they work, what are its advantages and uses, what are activation functions, and what are different types of neural networks, which will be going forward in detail. Thanks, guys. It was nice to take this opportunity. Thank you. Okay, let's proceed now. So now I'll be explaining an example with a use case. So let me take a use case. I have a data set, okay, so which is a data set of diabetic patients. So this is a data set, the Indian diabetes data set. So it has 9 columns, so 8 features and one outcome, 1 and 0. One is having diabetes, 0 is not having diabetes. So there are 7 features based on which I am detecting whether a person has diabetes or not, without even going through a penetration test or something. Without extracting blood or something, just by having these records, I can predict whether a person can have diabetes or not. Okay, so I have 8 features and one outcome. Okay, and this is downloaded dataset from National Institute of Diabetes and Digestive and Kidney Diseases. So you can get the source here. And the number of instances is 768 examples, and number of attributes is 8 classes. Uh, so, what is the first attribute? Number of times being pregnant, plasma glucose concentration, diastolic blood pressure, tricep skin fold thickness, 2 hour serum insulin, sorry, body mass index, diabetes degree, function, age, and lastly outcome 0 or 1. So, what is 1? Tested positive has diabetes, otherwise 0, no diabetes. So, it says 0 or 500 instances, 1 is 268 instances. Just check the standard mean and standard deviation also here. So these are the records. So this is the first one is what, uh, number of times being pregnant, and a last is age. Okay, so 6 times being pregnant and the age is 50 years. Okay. So there is a lot of data, 768 records. So there is a person with 5 times being pregnant and the age was 38, 55, 35, 28. My god, it's a low age. So I think there's a good data here. Let's go and implement our model with this dataset. I have already downloaded this dataset. I have it you know here. I'll just copy this path and let me go there. The use case is what? Predicting diabetes existence. Okay, fine. So that is my use case. So I will be using Python Keras. So the prerequisites for this library of Python Keras is you should have TensorFlow installed, and you should have Cborn installed to make our uh, to make our view if required, to make our visualization if required, and you should have SciPy and NumPy installed, and TensorFlow and Keras installed, obviously. And the steps I will be following are below. Okay, so how will I go through my lecture is by this. So firstly, I would loading my dataset. Secondly, I will define my Keras model. Thirdly, compile it. And fourthly, fit my model to X and Y. And then fifthly, evaluate it. And sixth is make prediction. Okay, these are steps I'll be following. So there are 768 records as you see. So let me get the dataset. The file name is this. I just copied it, right? This is the file name, Indian diabetes data. Okay, let me load it here now. How do I load it? So I need to import no, load text maybe, because I can load with load text from numpy import load txt. Okay, now I say load dataset equal to load txt of file name, and because it's a csv file, if you see it's a csv file, comma delimiter equal to comma, it's comma based, right? And I print my dataset. Sorry, okay, from numpy import dataset import load text. So I got an array of 768 records and 9 columns. Okay, so first 8 are my features and last 9 is my prediction. That I think we clear, right? Okay, so now I need to define my train and test, right? So what is my training? So it's the first 8 features, right? So I'll take X as my input, which I'm giving to my neural network, artificial neural network. Okay, so it's my data set of all the rows and 0 to 8 columns except the last one. Okay, and lastly y dataset is, which is my predicted or actual value, all the rows comma 8th column, right? So I will have my x and y defined input and the actual result defined. So now I'll be using sequential model. So in Keras, there are multiple ways of doing models, but the most preferred way for ANN, RNN, CNN is the sequential model. So sequential model, as it is like feed forward model. Uh, I'll define that. How do I define it? From Keras dot models import sequential. Okay, I need to also get my dense layer, because you need to have layers in your model at a neural network. So you have input layer, you have hidden layer, you have output layer, as we have already spoken. So all these layers are dense layers or the feed forward layers. So we need to have a layer, dense layers, used in Keras also. So from Keras dot layers import dense or dense layer. So there can be multiple type of layers based on the use case. So it can be convolution layer or any other layer, no whatever. So currently we are using dense layer for our basic ANN model. Okay, perfect. Now let me define. So what we have done, we have loaded dataset. We have defined Keras. We need to define Keras model now. Okay, so model equal to sequential. So it's my sequential model. Now I will start adding dense layers. So model dot add dense, and the dense layer input layer should have 12, 12 nodes suppose, and input dimensions equal to 8, and for every layer we have an activation function to go to the next layer. So activation is, what is it? By default we have spoken ReLU, rectified linear unit, because it's an input layer. We have activation as ReLU. Input dimension is 8, so the output comes as 8. Sorry, 8 features. Sorry, the input comes as 8 features, and this is my input layer. Now let me go to my hidden layer. This is the second layer, dense, and it has 8 outcomes, obviously 8, and I'll be giving 8 inputs to this, and the activation is obviously what? ReLU, because it has to go to next layer, the output layer, sigmoid functions or something. So now I have third layer, model dot add. I will add again the dense layer, and now, as we have already known, we have only one outcome, 0 or 1. 0 means no diabetes, 1 means has diabetes. So my input layer is defined, hidden layer is defined, and lastly my output layer after the activation should be single value. So I should have only one return result, one node basically, and the activation is what? Sigmoid. What is sigmoid? 0 or 1, right? You only get 0 or 1. You don't get anything else. ReLU, you get 0 or the value. It can be value can be 1, 2, 3, anything in ReLU. But sigmoid, you just get 0 or 1. So you're activating whether it's 0 or 1 and trying to predict the model. Basically, this is the outcome or the outcome node. If I take the example, see, input layer, the hidden layer. So here we have multiple hidden layers, but in the code we just implemented one hidden layer and one output sigmoid function layer. So here we'll have activation sigmoid function. Here we may have relu. Here we have input and the relu activation, hidden layer, relu activation function, and then sigmoid function, and then outcome. Okay, that's what I'm doing. I have three layers, and the outcome is binary classification. We want to predict 0 or 1, so sigmoid layer is the best for it. Right, let me do run it. Yeah, it's fine now. So model dot, I want to compile my model now. So model dot compile, and the loss is what? I have binary classification being going on, right? 0 or 1. So I will use binary cross entropy for the loss. And then obviously we need to have an optimizer. I will explain what is an optimizer in detail in next sessions. So optimizer, I have an optimizer equal to, by default it is Adam. And lastly, metrics. So metrics in which I want to train my model, focusing on. So I want to focus on accuracy, so I am giving the metrics as accuracy for my model. Okay, let me run it. Perfect, it has compiled now. So my model is actually compiled with dense layer and all these high-wire parameters. Now let me fit my model with the data. So model dot fit. Now my data comes into picture, x comma y, and what else? How do I fit the model? I need to also run on multiple iterations, the epochs. So let me take epochs as 150. So it is like continuously learning uh, with all the propagations going on. So it's learning with epochs again and again. So model outfit x comma y, input and output, to learn output, and x is the input. Epochs is 150 iterations, and then I want to train it in batches to avoid the computation issues. Batch size is 10, suppose. So batch underscore size is 10. So model dot fit. Right. The issue is the spelling epochs. Now it's training 150 iterations. If you see, my accuracy is increasing. See, and loss is decreasing. That's how it will help to fit the model with best epochs and batch sizes. So I have 768 records, epoch 1, epoch 2, epoch 3, and the loss is decreasing, the accuracy is increasing. If it's not going that way, then there's an issue with the model. So we have 150 iterations, and all the iterations are done now. Okay, perfect. So let me check now the accuracy. Model dot evaluate. I want to evaluate my x with y. Okay, and let me print the accuracy. And it's into 100, right? So I have 75.1% accuracy. It's almost 75% accurate model I got with my training dataset. Okay, let me predict now. Just check me. Let us learn how to predict it with the sample values. So model dot predict classes. I want to predict 0 or 1. Predict classes x. So I just give the x values. I don't have any test data set currently, right? So I just will give the train data only, and let me check the predictions, and let me see just top 5 predictions after that. So for I in range of maybe 5, print x of I, dot maybe to list, comma predictions. Okay, I think we should not confuse it, so let me do predictions and then predictions. of uh, I first one comma the actual output. Okay, so here this is the input, this is my prediction, and this is my output. Okay, let me write it here. Okay, let me print it first. Prediction spelling is wrong. Sorry, the comma is missing. Sorry. See, this is my input. The predicted is 1, actual is 1. 0 0 1 1 0 0 1 1. So it has trained perfectly. I have predicted it properly till now, and it was 75% accurate anyways with the X itself. So this is how you can actually train a simple diabetic model also with the particular instances, and train your neural network with just one hidden layer. Okay, I think this is the base for it. Okay, just go through it and you can do wonders with it.